thing is usually favorite way to learn is usually to do it myself. So that's the approach I'm going to take. So no slides, nothing. We're just going to attempt to create a project in Rust. Let me share my screen. So yeah, I hope you guys can see my screen.
Yes, visible.
Okay, so this is okay. This is the boilerplate you get when you run DFX new project name. So I run DFX new practice. We can do that here on the terminal. We just run DFX new practice. Okay, I'm running on the assumption that everyone in the call, one, you know what DFX is, you have it installed in your system. Two, you know ICP, you have built for ICP before, or you have an understanding of how it works, just like on a high level, very little bit. And yeah, that's the assumption I'm working on. So you should have DFX installed, you should have Rust installed, of course, it's Rust. And what else? DFX VM, if you need it to manage your DFX versions. I think I'm currently on DFX 15. I'm not sure. No, DFX 18. Oh, there's an update. Interesting. Anyway, yeah. So to create a new Rust project, what you do is you run DFX new and then project name. So whatever your project needs to be, if it is a healthcare system, if it is a fundraiser, if it is whatever it is you want to call your project, DFX new, project name, and you run that. And what you get is a boilerplate. So my version, I picked, if you're using DFX 17 and above, there's what is it called? There's a drop down you receive to pick the language you want to pick. After you pick a language, you're asked if you want to add a front end, what kind of front end you want. I picked no front end, and I also don't have internet identity configured or anything. So this is just a backend boilerplate. That's all we have. So this is the format you get. You get, of course, a readme.md, which explains what the project is about and how to use it, how to work with it. DFX.json. What the DFX.json file is, okay, what the DFX.json file is, this is where you're defining your canisters and this is essentially where you're defining your canisters. If I had a front-end canister, I would come here, add a comma, and add practice underscore front-end, and everything else that would be required of that canister here. So this is why you define, this is where if you're having trouble with deploying a specific canister, this is where you look at if you're coding on any of the internet identity, internet computer languages. So this is a constant in all the internet computer languages. We have the cargo.tom. This is where you're coming to define your dependencies. So our workspace is practice backend. If I had any dependencies, I would come here and add a section that says dependencies and then define them down here. So dependencies are essentially anything you need to install in your system. If you want to call ICCDK, if you want to call whatever, they're called crates in Rust, but whatever library you want. Yeah, exactly, the libraries. This is why you install your libraries. The cargo.log, this is what is created after building. So it looks at what is inside your cargo.toml and creates this log file. You're not supposed to change anything in this file. This one you're not supposed to touch at all. We have a git ignore created automatically for you when you run the FX new. So git ignore, we all know what a git ignore is. If you don't, please raise your hand or like speak up and tell me if you don't. We have a .env file. This is where all your Environment variables are, something's wrong. I don't know what is wrong. Oh, they can't go up. I think my computer is just died today. Everything is acting up. Anyway, yeah, so the .env file is your environment variable. So this is where your canister IDs are going to be stored, every single canister ID you have. So in this case, we only have one canister, the backend canister. That is what we are going, that's the only thing that I think is going to be in here. And then the target folder is Rust. Rust as a language compiles into a WASM, into a language called WASM WebAssembly. So the target file is the WebAssembly code that is generated when you go build your project. So that happens in all Rust files, not just on ICP. So the target file is just where the WebAssembly code is stored. And then your SIC folder, now this is where the code is supposed to be. And if only this entire page wasn't frozen. I'm sorry, let me try and run that again. I really apologize for the hiccups. It's been a long day of just coding, so I think even my computer is exhausted. So far, anyone who has a question, I don't know if we've gotten to a point of questions, but anyone who has a question who would want to ask it? If you do, just raise your hand and then, no, not raise your hand, just speak up and I'll answer you. I'll be able to hear you. Okay, I'll just take that as a no. We're back in action. Yeah, my screen is back on. Yeah, so, okay, when I share my screen, it refuses to go anywhere above that. Okay. Yeah, it's refused. Let me use Vim. Okay, so where were we? We were, okay. So we were defining the project structure. I cannot see anything above here. So I'll just do that here. Okay. So like I was saying, the target folder is your .wasm file, your WebAssembly code. So you're not supposed to touch that. It kind of generates itself every time you run deploy. So when you create a new project, it's essentially not there. But after you've created a new project and you have run it successfully, you get a target folder. You can call this whatever you want to call it, but I think the way DFX has been set up, it calls it target. But yeah, you can set it to say anything. You can call it anything you want. So the folder we need to concentrate on right now is the SIC folder, which is where we have our backend code. So yeah, here we also have another cargo.toml. So again, because we have different canisters, we have you'll have your backend and you'll have your front end, and maybe in some cases you might need more canisters than just the front end and the backend. You can have several SIC folders, and each SIC folder will have its own cargo.toml, which now will have the dependencies for that specific project, for that specific canister, if I may put it like that. The .did file, this one you get, this one is a ICP file. This is what connects you to the Candid UI. The Candid UI is a way that ICP makes it so that you can interact with your backend canister code without necessarily creating your own interface. You don't need to have a front end to test if your backend canister is working. They have something called the Candid UI, and you define what the methods that are going to show up in the Candid UI look like in the .did file. Rust, unlike other ICP languages, I know TypeScript, Azle, and Motoko auto-generate the .did file, so you usually don't even interact with it. But in Rust, you kind of have to define the functions that go there. So if I can show you the content of this specific file, it has the method that we have inside of course, inside the canister that we've defined, the method and the items it receives. So the method is greet, and it receives a text. So in the DID file, it's a text. Inside the lib.rs, it's going to show up as a string. The DID reads strings as text. Yeah, so it receives a text and it returns a text, and it's a query. A query, there's two types of methods on ICP. We have a query and an update method. A query method is a method that simply interacts with the data inside the canister and doesn't change anything. So if I wanted to get items stored in the canisters, for instance, if I created a user and I wanted to get a list of users, I'm not changing anything in the canister. I'm just querying it. I'm just calling to see the number of users that show up. An update method, on the other hand, changes the state of the canister. So an update method is a post. I wanted to say a put, but I found out yesterday that you cannot send a put request on ICP. I know it's in the works. I'm saying there's an issue sent to their GitHub, but yeah, at the moment you cannot send a put request to out from inside the canister to an outside entity. So yeah, an update function will be a post request, and then a query will be a get request. What else do we need to look at? Oh, okay. So finally, we're going to look at the SIC folder inside. Let me just. Okay, I haven't set that up. Never mind. So if we ls SIC practice, and we look at the SIC inside. Okay, sorry. We have a file called the lib.rs. Now, this is where all of your logic is going to go in. Again, this is just a backend canister, so all of your logic is backend logic, and the lib.rs is where all of your logic goes in. So if we go into the lib.rs, that's what it looks like. So what we have in here is a query, as we had seen inside the DID, and it's a greet function. So the boilerplate gives you a greet function. And the greet function essentially just asks you for your name. So it takes in a name that we had seen was a text, so a string, and it returns a string. The string it returns is hello, your name. That's essentially the canister that we have in there. This declaration up here at the top, when you say IC CDK query or IC CDK update, what you're doing is you're making the query available outside of this page so that it can be read both by the DID file and now with your front end when you want to interact with it. So far, because the next part is now we start coding. So far, anyone who has any question? Any question at all? I'm going to take the silence as a no.
Just a minute, Chris. Maybe they can send their questions on the chat box if they are afraid of speaking. As you continue, they can be sending their questions so that I can read them out to you.
Okay, yeah, that would be nice.
Yeah.
Okay, so what I wanted to do for our function was a simple, what's it called? A simple counter method, one that simply adds, say, A plus B, or adds two numbers essentially. So let me delete everything that's here. The problem with using Veneer, it's so slow. You can't just copy paste things and delete. But anyway, yeah. So if we created, so of course this is going to be it's going to be an update function, because again, this is going to be a function that is going to be changing the state of the canister. So that if we start with our number as 0, once we run our counter, the number is going to change. So the state of the canister is going to change. So it's an update function. And then, of course, we're going to do fn. Let's call this counter. And it takes in, say, a. A is a integer. In ICP, integers are integers. I'm sorry, I'm a bit tired, so my brain is a bit foggy. Yeah, so in ICP, integers are represented as a value called a nut. Strings are just strings. Yeah, essentially. But yeah, it's going to take A, that's a nut, and say B, also a nut, and return a nut, again, a number. Wow, this is slow. I miss using VS Code. And then, so we have a counter. Give me 1 second. Let me confirm something. Okay. Wow. Everything is so much slower today in this. That's fine. Let's go back to the code. So yeah, so fn counter takes in a number, takes in 2 numbers and returns, of course, a number. And then here we say, oh, okay, let's first define, okay, let's define it in here, it's fine. Let's define a count. Let count be equals 0, right? And then, although if count is equals to 0, then why are we taking in values at the top? You can just plus. So it takes in nothing, and it just adds. And then, my brain imekata. It's refused to get this done. So if we have that count be equal 0, and then now we do count plus equals 1. And then we return count. I'm not sure this is going to work. This one is all from my mind. Anyway, it's fine. Let's see what happens when we try to deploy this. So we run dfx build. Oh, sorry. Of course, you have to start the internet replica. And then we run dfx build. Okay. dfx build practice. Oh, dfx create. Okay, let me just run dfx deploy and see what happens. Okay. Oh, okay. Yeah, that's the problem. Okay. We need to import from ICCDK, we need to import the NAT value. Use IC underscore CDK. Let me confirm this. Let me confirm what this import is supposed to look like. Give me a minute. Or if anyone has an idea, you could like tell me what that input's supposed to look like. I'm sorry.
Maybe Dedan, Emmanuel, Silas,
Yeah.
can help.
Oh. Are they still in the meeting?
Yeah,
Look for my files.
yeah. I don't think Dedan is here. I can see Emmanuel is here. Emmanuel, can you help with that?
I know you're supposed to import it. I'm trying to figure out how.
I don't think Silas is not here.
It's okay. It's okay. I think we can just scrap that for now.
There's an answer. She just sent an answer. Just look at the chat box.
I can't since I'm sharing my screen. I'm on a different screen. Let me see.
He has sent you a code, something to use. Just minimize the Zoom screen, then you can see, check the chat box.
Everything's just messed up. Okay, there we are.
Okay.
Oh, I see this. Okay, yeah, I see that. I see it. Export,
Okay.
yeah, thank you.
Thank you, Dedan. Thank you, Manuel.
Oh yeah, that's something else about coding. If you're used to doing Web 2, if you're used to doing like the normal coding on ICP requires you to import all the types that you need to use. We don't use integers, we use nuts, but you need to import the nut type from. You need to use the nut to import the nut type from ICCDK itself. Oh, and because we have added that value here, we're supposed to use it as a crate, we have to import candid. I think it's candid types, the crate itself, right? Or I'll just import ICCDK as a whole into the file. So WQ, and then go into our cargo.toml. In this case, we're going into the one inside the practice backend. Oh, it is imported. It is imported. Even Candid is imported inside our tiny little cargo.toml inside the backend canister. code. So let's try running that again. Not find export inside ICCDK. Okay. So let's try to just choose Candid, because I've seen Candid, okay, Candid types number, yeah. Try that instead. The beauty of doing it yourself is we learn along the way. So yeah, I came here so confident that we could do this together and I could show you how it's done. And here I am struggling. So, you know, at least, you know, even as people who seemingly know what we're doing, still struggle with these things as we move. Just how coding works. Oh, okay, it's not returning anything. I did say count, but let me try and say return. Not but found return type. Huh. Okay. Am I returning this wrong? They say let new count be equals to count plus one, and then returned new count. Not sure if that will work better.
Yes, how about you try macros?
Sorry?
You try CDK macros.
No, the problem is not the import. The problem is how I'm returning the value. It seems to not notice the return value. Okay, let me see why that's happening. Oh, or what do you mean, Dedan? Please explain further. I don't know if I'm understanding you.
What I'm trying to say is you try using the ICCDK macros that they can encapsulate everything together. Like you just say use ICCDK macros, then you tag everything. You just put an asterisk at the end of it. Like it brings all the imports that you need.
Oh, like as a whole. Oh yeah. Oh yeah. Okay. But the error we're getting right now is not that it's not an import error, it's It's a value, the return value I'm giving, because I have told the function that it's receiving nothing and it's returning a nat value, but it seems to not notice the new count, which is supposed to be a nat value. That is what the error is saying, essentially. So yeah, I do not know if I am returning wrong, so let me just confirm that. Because the one day you need Google to work, Google starts slowing down. Interesting. Okay, so I think the problem is with the way I am incrementing the value. Because count is a local variable, the return function is not seeing it according to the explanation I've gotten. So let's take a different approach. I am going to import a crate called refcell. The refcell, if you've used it before, the refcell crate and okay, the crate. Refcell and cell are essentially ways to handle the immutability of your code. So you kind of make, I'm not sure if it's making mutable code immutable, but yeah, something like that. So it's how you create storage for your system. So the storage system in your canister, where you put, so in this case, our counter number, that's where we're going to be storing it. And once it's stored there, becomes immutable, which is one of the biggest selling points for ICP. So yeah, so we're going to import it from the std crate called refcell. And then we're going to create a thread local. So this is the storage points that I was talking about. A thread local is essentially, how do I define this? If you define a storage inside a thread local, it is available all through your canister as you create the function. So if I were to create a different function, I would still be able to access the storage system that I've created in my thread local. And your thread local is going to look like this. I'm sorry this has taken so long. If you got bored midway, I am really sorry. New.
It's okay, Chris, don't worry. We understand.
So it starts at 0, which is what we wanted to have our counter from in the start. And yeah. So now we have our thread local defined. Then now we have our function, the counter function. So what we're going to do is we're going to define counter, so counter dot with. So this basically defines the type of our counter. of the value that is inside our counter and defines it as the item that we're storing inside here. So this static counter is, I could call it a type. And now we're defining this to be this type. We're defining this value inside here to be the type that we're storing inside our counter. So pointer counter dot borrow plus equals 1. Pointer counter dot borrow dot clone. And then we close our brackets. I think that should do it. So let me try and explain what has happened. We have created a storage system essentially called a thread local. We have defined what our counter item is going to look like. It's going to be a NAT that is stored inside a ref cell, and it's going to start from the value 0. Then what we have done is inside our function, we have told our counter to increment by 1 every time this function is called. And then we've cloned that item. So that's this clone is what we were missing in the first place because it wasn't storing it. So when we tried to run it, our DFX, not DFX, our system was not seeing the return value that we needed. So when we clone it, this clone is what is going to be seen and is going to be returned at the end of the execution. So yeah, let's try this again. Expected one of, but it did get that. Oh, thread local is one word. I'm sorry. Yeah, it is one word. And I made it more than one. Underscore. Okay, new errors. A similar name exists in module, ref cell, no ref cell in cell. Okay. Not found in this scope. Use of undeclared type, ref cell. Consider importing one of this. Let's change one of those to this. That's what I have. Okay. That's what they suggested, right? Cell, STD, cell, ref cell. Yeah. That is the same thing. Genuinely stumped. I don't know why this won't run. But essentially, this is the process you follow as you code. This is embarrassing. Anyway, point is you need to figure out a way to import all your data types inside the file you want to use. So in this case, the data type we were using was NAT. And then you're supposed to figure out a storage method. If you're part of the inter-university hackathon, a lot of you have been coming to me with issues of how do I create a user? How do I create this? How do I make sure that I can log in? You have to create essentially a struct. So this isn't a struct. This just stores one number, but you can create a struct. A struct looks something like this. Since this has refused to work, I'll just use the same file. A struct looks something like this in Rust. You define struct, and let's say you want to create a user. You define that struct, and you define now what items are going to go into your user struct. So if you want, say, a name, what value is that specific key going to be? And in this case, a name is a string. So yeah, just define all those values. So you define the key, so a name, and then the value type is going to be. So if it's a name, it's a string. If it's date, okay, most dates are usually string. If it's a count, it's a number, like we've done with ours, it's a NAT. If you want to track principals, so the principals are the values on the internet computer that are technically addresses, like all the addresses on the internet computer. If you want to use a principal, of course, you import your principal value from ICCDK and then you use it. After you've created a struct, then you can store your values inside your struct, like whatever logic you end up giving out inside now your functions, inside your methods, they will be stored in these essentially in these storage units. Let's call them storage units. So there's several types. There's the struct, there's the thread local. I can't think up any other, but there's several, I swear. And yeah, anyone with questions? I'm sorry, my function refused to work even after looking for Amwa Kenya. If you're not from Kenya, Amwa Kenya is a cheat sheet. But yeah, that was me attempting to code in Rust. I hope you have understood the structure of a Rust project, 1, and 2, you have understood how to go about thinking about your project and how to code through it. Yes, Dedan, you've raised your hand.
Good job, Chris. I don't have a question exactly, just to say something. If you guys have realized that languages in ICP that are used to create smart contracts are somehow the same. Last week we were talking about Motoko, and we realized that we are using natural numbers, which are NAT and everything else. Today also you have been able to see the structure of the code base itself in Rust, and similarity is coming out from it. Okay, just to put across something small, maybe you guys might be trying to familiarize yourself about the mutability and immutability of these variables, because they are not exactly the same how they are declared. Chris has said about the update and the query, just the same as saying the CRUD operation, that is the get and the update, and also the immutability and the mutability of the variables. In Rust, I think it's a bit different. And the thing that I was trying to tell Chris about the macros is that using ICCDK macros, it enables you to encapsulate everything, like that create to define method that the internet computer can invoke specifically. Then it will be well used. Like you can just invoke init, query, update, all of those encapsulate in one ICCDK macros to avoid those trying to import everything at every instance of the function. Yeah, and I think with just that in mind, it's going to be cool. That's all for me.
Yeah, okay. Yeah, there's a lot. Yeah, thank you so much, Dedan, for adding all that. Yeah, I understand the ICCDK macros, so you don't have to import everything as you move. Yeah, I think it was imported. I think it is inside my cargo.toml. I just didn't import it into my file, but yeah, that's true. Something else you have to realize about coding on ICP, which I have found out over the last week, is a lot, okay, especially when you're using Rust, a lot of the crates that you can use while coding in Rust normally, most of them will not work on ICP. A lot of the imports you might think would work on, say, TypeScript, on Python, in a Python file normally, or in a TypeScript file normally, might not work on ICP. That's because when you run dfx deploy, or when you're trying to run an ICP program, it's not running on your local computer in the same way a Web2 application runs on your local computer. It runs in a sandboxed environment, if I may put it like that. That's why you kind of get, the link looks a bit different than when you run npm start or npm run with JavaScript. Yeah, so it's a sandbox environment, which means a lot of the things that you might find, things like the standard inputs, you cannot import them as you go with them. That sandbox is kind of enclosed. So there are some imports you cannot use. For example, and this I think cuts across all the languages, you cannot use .env to store your variables inside when you're using ICP. So you have to find, very interesting ways to store your keys or your important information that you don't want in your code. Another one that I found that was interesting was, yeah, of course, you can't use HTTP methods, not the normal ones. There's a specific enum, a specific library on ICP that has those. And of course, I don't think you guys are going to be using the HTTP methods soon, but yeah, you cannot use the normal HTTP methods in ICP. Yeah, and I'm sure there's going to be several other imports, several other crates you're going to find out don't work. So you kind of need to work with the ICP libraries. Something else I would like to note is, yeah, I think that is all I had to share today about Rust. Despite my methods and my functions not running as expected, I hope you guys have understood the structure of a Rust canister. I hope you guys have understood the reasons we have different files. And yeah, that is my lesson for today. Of course, I've been asking for questions all through, but if you have questions, if you have pointers, if you have, yeah.
Thank you so much, Chris. I appreciate that. Was fantastic. I don't think there's any question in the chat box. No, there's no question. We're past our time. It's at 8:10. So I'll just maybe give this chance to Tevin if you want to say something before we close the session. Dedan, you're saying something? You're clapping. Tevin, you want to say something? All right, I believe Tevin doesn't have anything to say. So that was fantastic, Chris. Thank you so much. I hope everyone got something from this session, and we look forward to hosting you in the next class. Thank you so much. Have a good night and see you next time. Bye. Or you guys want to chill here and talk? Okay.